Hi, it's Dr. Ray, and I'm here to talk to you about early cardiovascular development. At the beginning of the third week, we do have some blood cells that start to form in the embryo, but they actually are not going to form inside the embryonic disc, but they're going to form outside in the wall of several membranes, such as the umbilical vesicle and the chorion, and also within the connecting stalk. And so here you can see little blood islands that's in the wall of the umbilical vesicle. From this view, you can see the connecting stalk, but you can't see the chorion that's most outer membrane, that would be out here. And then the amnion has been cut away to show you the embryonic disc. So that's what you're looking at, and you can see these little sort of bubbles or outpouchings where the blood islands are, where blood cells are starting to form. And you can see they've ghosted some blood cells here within the connecting stalk. A couple days later, then we finally do have some embryonic blood vessels that start to form within the mesoderm in the embryonic disc. And you can see those depicted here in this cutaway section where the amnion is cut away, so you can see the dorsal side of the embryonic disc and you can see the primordial blood vessels. And this is about the same time that the embryo needs more nutrition and removal of metabolic waste. So all of this goes hand in hand. And there are two processes that occur within vascular system development. One is called vasculogenesis, and that's the formation of new vascular structures from the assembly of angioblasts. So angioblasts are the cells that are destined to become the blood cells or blood vessels, depending on what they get told that they're going to be by interacting with nearby cells. So we call them precursors. And so this is the original step that has to occur within embryologic development so that blood and blood vessels can develop. And then the second process, called angiogenesis, is the formation of new vessels from these original vessels. And so angiogenesis actually does occur even after birth, throughout life, in the repair process that you'll be learning a lot when you get to the second phase of your learning, which is abnormal development. And so vasculogenesis is actually the first step. And so here in these depictions from the Morse textbook, you can see the aggregations of these angioblasts in what we would call the blood islands. And here they're just using the example here in the wall of the umbilical vesicle. This is happening in other places as well. And so the angioblasts come in close approximation with each other, and they talk to each other, and they change shape, and they change function, and they develop further into an actual formed structure that will begin to have a cavity on the inside. So here you can see these cavities that are forming, and these cells are actually changing their arrangement and shape to be on the outside of the cavity. Some of the angioblasts will actually flatten and become specialized cells called endothelial cells. And here you can see those cells. They look different in this figure than the other cells that are lining the 2B vessel. And then also there are some angioblasts that are going to develop into primitive blood cells. And so cells will eventually take different forms according to their predetermined fates. And so the endothelial cells that you see lining what is this developing blood vessel are very special cells that have certain functions. And you'll be learning about these cells at length at first when you do histology. And these endothelial cells are easy to get confused. So I want to point out here that you're looking at these blood cells and these blood vessels forming from mesoderm. So endothelial cells come from mesoderm, and it's really easy later on to kind of think endothelial cells come from endoderm. So I want to point that out, that that's an easy mistake that is made. All of the blood vessels that we have in the body, head and neck are a little bit different with their origin of tissues, but in the rest of the body, they're all going to come from mesoderm. And so here you can see how the cavities inside these developing blood vessels come into close approximation with each other, and the growth and proliferation of the angioblasts continue, and it ends up looking like this. So you have a connected blood vessel with blood cells, primitive blood cells that are starting to form within the vessel. And so the actual intraembryonic blood cells, so here you have these blood cells that were made in the extraembryonic tissues, but intraembryonic blood cells actually occur much later, so that's in the 5th week, and that will be picked up by Dr. Hill when he does cardiovascular development. So we're just talking here about primitive blood vessels and blood cells. Now, the cardiovascular system is actually the first system to functionally develop in the embryo. And if you remember from the primitive streak making the mesoderm and it filling in between the endoderm and the ectoderm in most areas of the embryo, you might remember me briefly discussing the cardiogenic region. That is going to be a region that is cranial to where the notochord is located at. So it's around the prechordal plate, and this is going to be where the heart tube is going to develop into the heart and the great vessels in this region here. And it's going to change position due to the folding and changing around of the shape of the embryo, but at the very early stages, this is where it's located at. And so this will be continued when you do cardiovascular development. I just wanted to lay down the framework for very early cardiovascular system development so you had something to continue on with later. Thank you.